Hi, boys and girls. Today's lesson is going to be applying the distributive property to equations that have 3 as a factor. What is a factor? A factor is a number that you are multiplying. So let's think about equations where 3 is a factor. So we have been working on multiplying 2 numbers at a time. So we know that 1 times 3, we have 2 factors here. We have 1 as a factor and 3 as a factor. Let's think of another one. 3 times 2. Our factors here are 3 and 2. 3 times 6. Our factors here are 3 and 6. 3 times 9. Our factors here are 3 and 9. So factors are basically just the numbers we are multiplying. So when I say problems with 3 as a factor, that means one of these numbers need to be 3, okay? So we're focusing on just problems that have 3 as one of the factors. So we are going to look at an array here. And we are going to use the distributive property to solve for the equation this array represents. First things first, what does this array represent? Well, let's find our 2 factors. We're going to look at our rows because we're going to identify our first factor. And when we're reading arrays, we read the rows first. The rows give us our first factor. Here we have 3 rows. So we do have a factor of 3. That's the other factor. The other factor represents the number of circles in each row. And because this is an array and it shows equal rows and equal columns, we can use our columns to find out how many circles are in each row. 1, 2, 3, 4, 5, 6. So this is our problem. 3 times 6. Well, in order to solve our 3's facts quickly, we are going to use distributive property. That's why we have been working so hard at that strategy, because we are viewing this problem here in a different way. We know that we can use distributive property to break up a multiplication fact into smaller facts that we already know. So if we don't know 3 times 6 right off the top of our minds, we can break it down into smaller facts that we know. And we know that when we take the answers to those smaller facts and add them back together, that we will get the total amount. Because when we split the total amount, we are not changing it, okay? We're just viewing it in smaller units. For example, when we see 3 rows here on this array, the 3 rows here on this array represents this factor 3. But we could solve this problem even without this array. This array just helps us visualize what is going on. But when we see 3 as a factor, instead of seeing 3 as a factor, we can split that 3 into 2 and 1. We could show that, we can model that on this array by just drawing a line here. I just split 3. I divided 3 up into 2 and 1. Why? Because I know my 2's facts fast and I know my 1's facts fast. So instead of seeing 3 times 6, we see 2 times 6 and 1 times 6. So we know that if we take the answers to 2 times 6 and 1 times 6 and add them together, we will get the total amount. We will get 3 times 6. So we're going to do that. So as a visual, when we look at this top array here above the split, we see 2 rows of 6. Notice that the 6 did not change. Only one factor can change when we use distributive property. And the factor that's going to change in this lesson is going to be 3. We are always going to look at 3 and split it 2 and 1. I'm going to add that addition sign there to remind me that at the end, I need to make sure I am adding my answers to these 2 smaller equations back together to get the total amount. So, all right, I used 2. Now I'm going to use 1 here. This bottom part of the array is 1 times 6. Now these parentheses mean I have to solve whatever is in the parentheses first before I can add them together, okay? So I have to solve 2 times 6 and 1 times 6 first before I can do addition. So 2 times 6 is 12. I'm going to just drop my addition sign here to remind myself I'm going to have to add at the end. And 1 times 6 is 6. Now I know when I add 12 and 6, I'm going to get the total amount. 12 plus 6 is 18, meaning that 3 times 6 is 18. So when I do that addition at the end, it's the same as taking these lines and erasing them and putting that array together again. Remember, when we split the array, it doesn't change the total amount. When we split that 3 into 2 and 1, that doesn't change that factor 3. It still exists. We just broke it down into smaller portions. So you can easily solve these types of problems without an array. So I'm going to show you an example of that. And then I'll show you another example of it with an array. Actually, I'll show you another example of it with an array and then without an array. Remember, arrays are just training wheels. They help us understand math. They help us understand what is happening, gives us that visual. But eventually, we're going to take that visual away and we're going to be able to solve this without them. So this array, what does this array show? Well, let's look at the rows here. We have 3 rows. Do you see that? 1, 2, 3 rows. So that is our first factor. Remember, when looking at arrays, the first factor is always going to be those rows. Now, the second factor is going to be how many circles are in each row. Okay, and you can look at the columns and quickly identify that. There are 4 columns here. This is our problem, 3 times 4. Now, we know that we can split 3 into 2 and 1 or 1 and 2. Doesn't matter. We can decompose that 3 to 2 and 1. Did we change the total amount of 3? No, we just split it apart. We did this. Bloop. So instead of doing 3 times 4, we can use distributive property and do 2 times 4 plus 1 times 4. And we know when we solve for these smaller equations and add it back together, we're going to get 3 times 4. Oops. So let's do that. 2 times 8 is 2 times 4 is 8. Sorry about that. I had the answer in my mind before I solved it. And then 1 times 4 is 4. I know when I add the 8 and the 4 together, it's the same as erasing this a line here and bringing my array back together again. So I have 8 plus 4 is 12. Therefore, 3 times 4 is 12. Let's do an equation with 3 as a factor so I can show you that you don't need an array to solve these problems. You can do it without the array. So just to recap what we are learning, when we are multiplying by 3, we can find 3's facts by combining 2's facts and 1's facts. Basically splitting that 3 into 2's and 1's. So we could split that 3 into a 2 and a 1, do distributive property, and we have our answer. So let's go ahead and let's solve the problem here. Let's do 3 times 8. We're going to do 3 times 8. And we're going to solve this problem without an array. So instead of just seeing 3 times 8, we know that we can take this 3 and we can split it and make it 2 and make it 1. Why? Because 2 plus 1 is 3. So we just broke it down. We didn't change the amount of 3, we just broke it down. So now we know that we can multiply 2 times 8 and 1 times 8, add those together, and we'll get our answer. Let's try that. Get these lines back. So here we go. I have 2 times 8 plus 1 times 8. 2 times 8, I know that quickly, that's 16. You know why? Because any number times 2 is double that factor. So if I see 2 times 8, that's the same as saying seeing 2 groups of 8. So I know I can just double that 8 and I get my answer, and that's 16. Drop that plus sign. 1 plus 8 is 8. So this is when your addition skills come in handy. So if you're having problems with your addition, remember you can always count up. Okay, so 16 plus 8. Grab that 16, count up 8. 16, 17, 18, 19, 20, 21, 22, 23, 24. Meaning 3 times 8 is 24. Let's do another one. These are really fun. So remember, when you see 3 as a factor, you can split it into 1's facts and 2's facts. And then add the answers to those smaller facts together to get the total amount. So let's try 3 times, let's do 3 times 7. Let's do 3 times 7. So 3 as a factor. So instead of seeing 3 times 7, we can look at that as, I'm just going to show this as a visual. We know we can split 3 up into 1 and 2. So instead of seeing 3 times 7, we can visualize that as 1 times 7 and 2 times 7. Notice that since 3 is my first factor here, when I do my distributive property, only my first factors here are changing and splitting up. So I'm only allowed to split one factor. That 7 is consistent. Now, that's going to help you when you have those fill-in-the-blank problems, knowing that. Now, all I have to do is solve for these smaller equations and add them up, and I have 3 times 7. 1 times 7 is 7. 2 times 7 is 14. 7 plus 14, if you get stuck, grab that 14, count up 7. 14. 15, 16, 17, 18, 19, 20, 21. My answer is 21. My product is 21. Let's do it one more time, and then you're going to do an exit ticket. You're going to practice some 3 facts. So let's try it here. We have, I'm going to flip-flop some of these facts so you can see that it works both ways, it doesn't matter where 3 is in the problem. Let's do 9 times 3. So, 9 times 3. What factor do we want to split up? You've got it, 3. So instead of seeing 9 times 3, we know that we can split 3 into 1 and 2. So instead of seeing 9 times 3, we can look at it as 9 times 1 and 9 times 2. 9 times 1 is 9. 9 times 2 is 18. Add those bad boys together and we're going to get our total amount. 9 plus 18. Having trouble adding? Grab that bigger number and add up. Grab 18 and say 18. Add up 9. 18. 19, 20, 21, 22, 23, 24, 25, 26, 27. The product is 27. So, in conclusion, whenever we see 3 as a factor, we can look at it as, whenever we see 3 as a factor, we can decompose that and look at it as a 1 and a 2. So we are going to go ahead and I want you're going to practice some 3 facts today. You're going to practice some 3 facts. And I want you to think about this concept as you solve for those 3 facts. I'm also going to give you an exit ticket where you are going to have an array with 3 as a factor, and you are going to split it using distributive property. I will see you tomorrow.